We're going to look at how to run a confidence interval or create a confidence interval using the Statskingdom website. So this is I'm trying to zoom this in. Here we go. Okay, so this is going to be a estimate of a population proportion. It says assume that a random sample is used to estimate a population proportion P for a U.S. president's job approval rating. If you go to this website, it just goes to Wikipedia page describing what that is talking about. It's not actually, like, you don't go there to get any data. Find the margin of error, EBP, so that's the error bound for the proportion that corresponds to a sample of size n equals 967 and a sample proportion of p prime equals 63% that approve of the president's job performance at each of the following confidence levels. Apply a stat key simulation for the sampling distribution or use the central limit theorem. So we are going to ignore these directions and use Statskingdom. So Statskingdom seems like it does just about everything. And if you don't have it bookmarked, you should be able to just Google that and then click on the first link. And if you scroll down till you see confidence interval, here's confidence interval calculators. And we're looking for proportion. Later on, we will look at this stuff about difference between two proportions, but this is just one proportion. Okay, so this particular problem asks us to do 3 different confidence levels and then find the error rather than actually find the entire interval. But we'll just look at all 3 of these and look at the interval as well. So 90% is going to be our first confidence level. N equals 967. P prime equals 63%. So let's see what all we need to put in. So change that to 0.90. Sample size was 967. Yes. And then sample proportion or number of successes. And notice it has P hat rather than P prime, but it's the same thing. So since they gave us 63%, that's what I'll use. Yeah, so 0.63. We could multiply that by 967 to get the number of successes, but obviously there's no need. So calculate. All right, so here's our confidence intervals because they have different methods, or they're showing different intervals using different methods. So we have learned to use the normal approximation to find a confidence interval about a population proportion. So this is the interval in blue here. And what they actually want, though, is this margin of error. So here's our point estimate, 0.63 right there. And then the margin of error is what we're adding or subtracting to create our interval. So I'm just going to copy and paste that in. Oh, it wants a percent. So I need to put that as 2.554. It says accurate to at least 1 decimal place. So I'll just do all the decimals it gave me. So 2.554. And so to do 95%, we just go up here and change this to 0.95 and hit calculate again. And so here's our new margin of error. So 0.03043, so 3.043%. And then for the last one, 98%. Calculate. Here we go. So here's the last margin of error, 0.03612, so 3.612. And the nice thing about this website, other than it's, kind of foolproof, if you know even just a little bit about this stuff, you can kind of figure it out. But the one nice thing is that it allows you to put in any confidence level. Megastat only has 3 different confidence levels to choose from, at least as far as I can tell. Okay, so then we can see as our confidence level increases, we also have to increase our error so that the interval itself gets larger. Oh, shoot, I should have read directions here. Round final answers to 1/10 of 1%. So I'll just go ahead and do that, even though when I click in the answer box, it's giving me slightly different directions. That does seem to be a theme in my open math. So as the confidence level increases, margin of error increases. Yay! So there we have it. So this is creating a confidence interval to estimate a population proportion using Statskingdom or statskingdom.com.